This is problem 2. It says we have a D4 die that has numbers 1, 2, 3, and 4, each with a 25% chance. So it's just an even die, or a fair die. I plan to roll a D4 and a D6, which is a standard die with sides 1 through 6. So what is the chance that both dice show the same number? There's 2 ways you can do this. So on the key, I've already shown how you can list out all the outcomes. That's just a way to help me organize my thinking. You don't have to do it that way. So I'm first going to show you how you would do it without remembering to list out the outcomes, because I know you've all said, well, how do I know that I need to list out the outcomes? Well, for me, if I can do this without having to list out the outcomes, like if I look at it and say, this is easy, I just go ahead and do it. If I look at it, I'm not sure what to do, then maybe drawing some kind of diagram or listing outcomes might help me. Okay, so what is the chance that both dice show the same number? Well, let's just write it down here for us. A D4 has the numbers 1, 2, 3, and 4. And a D6 has a 1, a 2, a 3, 4, 5, or 6. So to actually get both dice to show the same number, what does that actually mean I have to do? Well, that means I have to get a 1 and a 1, or I have to get a 2 and a 2, or I have to get a 3 and a 3, or I have to get a 4 and a 4. Now you can find each of these probabilities using things we know how to do. So like if you want to get a 1 on, let's say we're going to do D4 first for everything. So if you want to get a 1 on a D4, it's going to be 1/4. And means times. Now I need to get a 1 on the D6. Well, that has 1 1 out of 6 options. So it's going to be 1 out of 6. For an or, we're going to add. So it's like this gives me my 1 and a 1. Or it means I'll add up. Now I need a 2 or 2. So for the D4, I'll have 1, 2 out of 4 options. Times, to get a 2 on the D6, I have 1, 2 out of 6 options. Okay, and basically you'll see it'll be the same thing. To get a 3 and 3, it'll still be 1/4 times 1/6. And to get the 4 and the 4, it will be 1 out of 4 options and 1 out of 6 options. So 1 out of 4 times 1 out of 6. If I add all of that up, I get 4 out of 24, or 1/6, depending on how you put this into your calculator. So that's how I can do it without listing out all the options. But if you want to list out the options, if you looked at this and you didn't know what to do, okay, or it's just a more complicated problem, I might do it. Actually, now I don't remember. I'm sorry if on the key, I think I did 1, 2, 3, 4. Maybe if I'm flipping this, I'm sorry. It doesn't matter which way you do it. This is just to help you organize. So if these were all of my options, this is the D4, this is the D6, I could just go through and put a star on all of the options where they're the same. So like a 1 and a 1, a 2 and a 2, a 3 and a 3, and a 4 and a 4. So you'll notice this was 4 possibilities to get what I want. And if you envision this as a grid, I didn't actually draw in the grid, but if you envision it as a grid, there are 4 things that have what I want out of 24 total. So that gives me 4 out of 24. It was just a much easier way to do it if you weren't sure what to do. Okay, let's see, for B, what is the chance that at least one of the dice shows a 4? So anytime you want at least one, so let's just do it without the visual first. So if you want at least one to show a 4, the probability of at least one is equal to 1 minus the probability of no 4s. So let's see if we can figure out what that would be. So to get no 4s, we would have to have a not 4 on the first dice and a not 4 on the other dice. Okay, so that's what we'd have to have on both dice. So for your first dice, you have 1, 2, 3 numbers that are not 4s out of a total of 4. And on the second dice, you have 1, 2, 3, 4, 5 numbers that are not 4s out of a total of 6. So if I put that into my calculator, and let's see what this is going to give me. Should give me 9 out of 24, or 3/8. So again, you can do all of these logically many times on probability. There's more than one way to do it. This chapter in the book, they were just showing you, hey, you can do cool things like this. It can help you. So if I wanted to do it with my chart, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, I want to have at least one showing a 4. So that would be anything along this bottom row. So that's 6 things along the bottom row, or 1, 2, 3, 4 things going down. Now let's count them all up. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Notice we don't want to double count that. was in the row and the column, but we don't double count things. So we had 9 possibilities out of 24 spots to give us what we wanted. Okay, let's see. C. C is the reason I actually do these. I find it is so much easier to do with the graph when I want a total. What's the chance that the total from the 2 dice is 2? Okay, well, so to do this, I'd probably actually write 1, 2, 3, da da da, 1, 2, 3, da da. And I start actually writing the total. So 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 3 is 4. Let's see, 1 plus 2 is 3. 1 plus 3 is 4. 2 plus 2 is 4. And so you can fill it all out, and then you go back and count how many have a total that's equal to 2. Well, in this case, there's only 1. So the probability that the total is 2 is going to be the probability that we get a 1 and a 1. Which to get a 1 would be 1/4, and to get a 1 on the other die would be 1/6, so 1 out of 24. So either way you look at it, there's only one way to get a total of 2 out of 24 options, so 1 out of 24. Okay, but D, what is the chance that the total from the 2 dice is 8? This is much, much easier if we go ahead and draw that out. Let me see if it's in the key.